Hello, everybody. With a focus on recycling materials from products that are notoriously difficult to recycle, this company is reshaping our approach to technology and the environment, and they just have a very innovative process. Second. They just have a very innovative process in not just about recycling, but about revolutionizing supply chain, reducing our carbon footprint, and making sure the most tackling part of the environment, which is rare elements, is fixed, is a solved issue. With this, let me introduce Cyclic Materials. Hi everybody, welcome to another episode of Builder Nation. I'm your host Sam, and today we are joined by Ahmad Ghahreman, CEO, President, and co-founder at Cyclic Materials. Just since 2021, this is a very short company, very young company, but already making some great strides. Ahmad, welcome. Thank you very much for joining us. Could you please introduce yourself a little bit?
Absolutely. Sam, thank you so much for inviting me to the show. Ahmad Ghahreman here, as you said, co-founder and CEO of Cyclic Materials, and I'm really excited to be here.
Thank you. Thank you very much for that. So, as I mentioned in the very quick intro, that was a little that was a little off. I mentioned that Cyclic Materials, what you do essentially is tackling some challenges within the recycling industry, right? Especially for rare elements, trying to make what the concept of a circular supply chain. Could you please explain to us, before we begin with everything tech and everything related to your efforts, what is this concept of the circular supply chain?
Oh, absolutely. So basically, as we go forward in the future, we want to be nice to the environment, and we want to utilize every piece of product that we have in our everyday life to the full extent that we can. I'm going to make an example of it. Let's take lithium-ion batteries that we see a lot of it in our everyday life, in our electric vehicles, in our power tools, and everything and anything. Lithium-ion batteries are pretty expensive products. So basically, the effort is that we use those lithium-ion batteries. If they go bad, we try to fix them up. So refurbish those, repurpose those. For instance, lithium-ion batteries of the cars, automobiles, EVs. They are now being put into the garage just to store the electricity overnight and then use it in the day, or the other way around, and also recycle them at the back end. So recycling basically is the last piece of the puzzle. If you can use the product, reuse it, repurpose it, refresh it, and reuse it. But if none of those are possible, then recycle the material. So those are the four concepts within the circular economy. And to be sustainable globally, our economy needs to move towards circularity.
All right, thank you. And now, for those who might not be really familiar with the second part of the intro, which is about rare earth elements, sorry. To those who might not be familiar with it, why are these elements particularly such a big deal, really, when it comes to the recycling sort of whole process? Why are they so difficult to recycle?
Absolutely. Let me take a step back and tell you what rare earth elements are.
Yes.
We didn't learn much about rare earth elements in our high school, or maybe even in our university. So rare earth elements are collectively 15 plus 2, let's say 17 elements in our periodic table. They happen to be majority of them at the bottom of periodic table, which we don't even study in high school, I believe.
Very rarely, yeah.
But we need those rare earth elements in order to make the most strong magnets that we know in our planet. Now, why we do need most strong magnets? The reason is, when we produce or manufacture electric motors, the stronger the magnet we put into the application, the stronger and more efficient the electric motor will be. Now, we are paying a lot of money for lithium-ion batteries because those are expensive. It just makes sense to have the most efficient electric motors hooked up to those batteries. So the electricity we consume is efficient in that process. Now, rare earth elements are mostly used to manufacture those strong magnets, and the strong magnets are used to manufacture very strong motors. Where do we see those electric motors? The electric motor at the core of electric vehicles, majority of them contain those magnets. A lot of power tools that we use every day in our life
Hmm.
contain those strong magnets. MRIs, wind turbines, the
Yes.
generator of wind turbines contain those magnets. A lot of speakers that we use in our everyday life, probably the headset you
Yeah,
have
yeah,
that
most
with
likely, yeah.
magnets in it, probably are neodymium magnets as well. Now, when we use rare earth elements to make those magnets, often we call those neodymium magnets or neomagnets or rare earth magnets in brief. As we go towards electrification, we do more of storing energy and consuming energy.
Hmm.
And to be efficient in consuming of that energy, we use more and more of those magnets in electric vehicles and other applications. That's why rare earth elements are becoming an important and critical ingredient of electrification.
Right. And now this actually, thank you very much for explaining that. That was even better than I could have explained. Um, Now, this leads us to why the inception of Cyclic Materials came to be in the first place, right? Back in 2021, before we started these, we were chatting very quickly, very briefly about how you started in a different company back in 2016, and then it was sort of evolving into a different path, and you saw this opportunity to create Cyclic Materials. When you first started this company back in just over 2 years ago, very, very recently, I mean, it's grown quite a lot in these past 2 years. How did you first envision the part that cyclic material is going to play in all of these circular supply chain and recycling sort of path?
Absolutely. Yes, you're right. We are only 2 years and 1 month old. Our company was created back in October of 2021. So I've been in the space of sustainable metals extraction and recycling for quite some time. I have created multiple technologies that are at the core of many different companies. One of those technologies that I have helped to co-design is at the core of a battery recycling company. And that battery recycling company basically was looking into battery recycling back in 2016, 17, still around a successful company. Uh, uh, but through the life of that company, my focus also was my attention also was brought to through actually a car manufacturing engineer to some other set of metals in traction motor of electric vehicles that are critical to manufacture electric motors. Those are, of course, rare
Hmm.
elements. Now, two things happened in 2021 that I decided that this is the time to start Cyclic Materials. The first thing was the numbers for sales of electric vehicles and offshore wind turbines in the market, which are the two key drives of magnet consumption or rare
Hmm.
earth consumption, were skyrocketing. People were welcoming electric vehicles more and more, and they were buying more of those electric vehicles in North America, Europe, and Asia.
Hmm.
The penetration of rare electric vehicles into the everyday life of people was incredible to see then. But the other piece of information was that I reviewed in a report that less than 1% of rare earth elements are
Hmm.
recycled from end of life products. That hit me in the face, actually. That was pretty tough to take, simply
Yeah.
because if you go back and look into the root of rare earth elements, the only source for rare earth elements is mining.
Yeah.
You have to mine rare earth elements and have those metals. Uh, it is quite polluting practice to mine rare earth elements, and there's a lot of noise around it.
Hmm.
And happens that one country produces majority of the metal globally or the magnets globally. So that adds a lot of risk in the supply chain as well.
Hmm.
So put those information together, I decided to change that. And Cyclic Materials was born, and the technologies around Cyclic Materials to solve those problems, to recycle rare earth magnets from end-of-life products and produce raw materials that you would require to manufacture fresh magnets is what we produce as a product. And here we are, going really fast and trying to
It
be
really is
uh,
fast.
yeah, trying to make an impact in this space.
That's actually very fast. And I'm very curious about something. Now, you already had your experience when you started in the recycling sort of industry in 2016. how different or how much did you have to learn to really start a solid recycling sort of process for rare earth elements in these past 2 years? Like, how much have you really had to go like, okay, I thought I know about this, I totally didn't, and you had to just really immerse yourself into it?
I'm gonna be honest with you, Sam. Some days I wake up and I feel like I have a deja vu because it's pretty much the same space. It's helping the circularity of our
Mm-hmm.
electrified society. That's what I do. Uh, and sometimes, some days, the days couldn't be more different than battery
Yeah.
recycling days. So really it's a combination of the two. But overall, I'm going to say key one of our key feedstock sources is electric vehicles.
Mm-hmm.
And there's a lot of similarity in recycling of traction motors versus other parts of the electric vehicles. So from that perspective, some days I feel I feel like we are doing this. I'm doing this for the second time, but in some other days we are looking into many more different feedstock sources, and
Right.
those are a little bit new creations in the process to put together and work through the process and develop the process as well.
Right. Then this does raise a question for me. If the industry is not very different from general recycling to, or maybe lithium recycling to rare earth elements, and you've already mentioned that it's a very sort of dangerous sort of status quo, right? The fact that most of rare earths come from mining, and most of the mines are in very specific or single countries, which is very, it can affect the supply chain, as you mentioned. Why do we not see more companies tackling the rare earth element recycling sort of challenge?
So that's a great question, Sam, and I think we have a healthy list of competition out there. So it's not just us in this
Hmm.
space. In North America, there are in U.S., Canada collectively, there are I
Yeah.
think I can count 5, 6 companies that are attempting to solve the problem. There are quite a few more in Europe. So there are some other startups around in Europe and North America that are looking into solving the rare earth recycling problem. What we bring to the table is a bit different vision on how
Hmm.
this problem has to be tackled, and that has to do with looking into the supply chain a bit more holistically, looking into different magnets that will require recycling. Overall, there are four main categories of
All right.
magnets in the market: neodymium magnets, samarium cobalt magnets, ferrite magnets, and alnico magnets. And
Hmm.
we are focusing on recycling all of those and every one of those. So our process is basically magnet agnostic. So that has been part of the core vision we have had for the company. We have other byproducts in the company such as copper, aluminum, steel, nickel, cobalt, and that makes us a bit more multi-metal company rather than
Hmm.
just rare earth company. So those are some of the flavors that we have in the company that differentiates us from other competition, and few more that I can't really publicly announce here, of
Yeah.
course. Uh, but at the same time, we are really excited and we are happy to see that the competition is out there because, Sam, that's one indication that this space needs attention.
Hmm.
And other people also like us in our company are thinking about it. So that's a good thing. So we appreciate
Yes.
the competition we have in there.
It is a good thing. I totally agree. In fact, that is the reason why I asked, because it's not a very popular industry compared to many others that are far more, if you will, flashy, maybe like drones, robotics. But it's very nice to know that there's a healthy competition out there. But now this
Oh
also
yeah.
raises another question for me. Okay, now moving into the actual process that you follow, right? The very first thing that comes to mind is, well, you need to get the material somewhere so you can start recycling. You need to get your waste, if you will, somewhere, right? So the first question that I have is, where do you get the original sort of source for these elements to begin the whole recycling process, or rather the whole metals instead of just rare earths? Where do you get this from? And the second question is, which we're gonna tackle in a minute, but how much do you feel, or what percentage of the real waste out there is actually arriving to these recycling companies like yourself?
two really good questions. So the first question is, what are the
Where do you get them
sources
from? Yeah.
of where do we get the magnets from, or end of life products from?
Yeah.
Uh, uh, so end of life products come with really large entropy, and what I mean by
Hmm.
that is people consume products,
Yes.
and wherever there are people, there are end of life products. So end of life products are distributed globally. So you need a bit global vision in order to tackle the recycling
Yes.
industry. So that's step one. Step two, the easy target for recycling companies to basically establish themselves is
Yeah.
the larger cities, and obviously reason because simply they have more population, larger population, they consume more products, so more end of life products. Now, where we get end of life products to recycle from waste yards, from companies that manufacture or
Hmm.
receive end of life products. Those are the companies that we communicate with we work with, and we get the end of life products from. Now, few categories of end of life products that I can mention on the call is, for instance, electric vehicles.
Right.
We could communicate with the companies that manufacture the electric vehicles to get the production waste or production rejects from them.
Hmm.
We could also walk into end of life car recycling companies and ask them for the traction motor or the big electric
Yeah.
motor of those electric vehicles for recycling. So those are the sources of where we get the traction motors, recycling yards, manufacturers, and whatnot.
Right. Now,
Now,
this. Oh, sorry. Go ahead. You were saying.
no. I was going to ask you to repeat your second question because I already
That's
forgot.
that's totally fine. It happens to me sometimes that I get caught in many questions. Doesn't matter. The second question was, and I believe this is probably not more important, but far more interesting. Out of the 100%, or rather, I mean, you receive a lot of products, right? But how much or how many recyclable things are out there that simply just never reach a company? Like, for example, you mentioned you go to manufacturers, you go to recycling centers that they receive it, but if the end consumer doesn't proactively go and leave their devices somewhere where they can, make sure that the disposal is properly done, naturally there's going to be a lot of waste that is never going to end up being recycled. how much
Absolutely.
how much percentage do you believe, out of the 100% of consumer products or end life products out there, what percentage do you believe is the one that you actually get to recycle, and just how much is lost?
Okay, great question. We are actually just scratching the surface on that. The volume is significant of the material that we could recycle, but today are ending up in landfill.
Hmm.
We communicate with companies after companies after companies that, hey, you have this base of magnet that we can help you with. They say, oh, we didn't know that you can recycle those. They're going to landfills. And and quite frankly, we are here to change that because these magnets, in order to mine those magnets, we have put a lot of carbon dioxide in the atmosphere in the country
Yeah.
that produce those, mine those. Now, putting those into landfill is the last thing we want to do. So recycling comes with really attractive
Hmm.
environmental benefits. So we want to recycle those. Now, I can tell you that majority of the feedstock of magnets that we find, or the end of life products that we can recycle, uh, most of those companies, up until before knowing us, they would have been basically putting those end of life products,
Yeah,
the
they didn't
magnets,
even
into the
know.
landfill. They didn't even know that you can recycle those magnets.
Wow.
Now I can give you some numbers and stats in there. So for instance, just in the US, we are importing around 12 to 15,000 tons of magnet per annum.
Okay.
Those are tied up to other parts or equipments. For instance, you import those speakers, they come with
Yeah.
magnets. You import hard disk drives. Every single hard disk drive comes with a magnet in the corner. You import traction motor of electric vehicles, those would come in with magnets. You import those scooters, I don't know, e-bikes and all those, their motors
Yeah.
come with
Yeah.
magnet in them. So we import the volume of magnet. Recycling is basically zero. So so you can see that
Wow.
this market really needs attention.
Right. So it's very interesting to compare it with what you mentioned previously, right? That there is a healthy amount of competition out there, but it seems to me like there needs to be more in terms of just comparing to the volume of how much things can be recycled, right? And that leads to a different question that I have over here, and it is related to the fact that you said, well, we approach companies and they go like, well, I didn't know that was possible. How how much of an education effort have you noticed is necessary when it comes to the recycling thing? How much do you really need to educate?
Significant. So we spent a really good portion of our days in our strategic partnerships team, which is our business development
Yeah.
team, on educating people. So we do a lot of that. A lot of companies that we talk to, they are unaware of some of the aspects that we have to tell them what our offerings are, what how we create circularity in the supply chain.
Hmm.
And you would be surprised that with smaller companies, if you have that conversation, I'm less surprised. But with larger corporations, when we have those conversations, to be honest, we are a little bit surprised time to time.
Wow.
Not all the companies, but some of the companies will ask us some fundamental questions, which tells us that this is really a space that has been ignored in the past for a good reason. Because in the
Yeah.
past we didn't consume much electric vehicles or applications that rely on the rare earth elements,
Yeah.
and the consumption of those metals is skyrocketing only in the past few years, and we have just realized that, oh my goodness, we are really dependent on those metals. We are really dependent on one country. So we got to change that.
Hmm.
And we got to have secure supply chain. And those questions have popped up very recently in very past few years. Uh, uh, that's why the Department of Energy actually in the US has started putting together a list of critical metals. And those are the
Okay.
metals that we need for our future in North America and Europe and other countries. Uh, and those metals are critical simply because either US, Canada, Europe, they don't produce it.
Hmm.
The supply chain is really tied up to one or two countries.
Yeah.
Uh, the expected volume of those metals to be consumed in the electrified society is significantly higher than what it was. For instance, lithium is in the list. Lithium, we didn't use much lithium in ICE cars, internal combustion engine cars.
Right.
In electric vehicles, we use a lot of lithium. Same is true for rare earth elements. That's why rare earth elements are one of the key metals in the critical metals list. In fact, in the criticality range, rare earth elements are among the most critical metals identified. There are red metals in there actually,
Hmm.
and how critical they are,
Yeah.
and that has a story to tell because it tells you that we didn't really use a lot of those metals in the past. We're using quite a bit of those now. We are expecting to use much more of those metals in the future. We just are not producing enough of those. So recycling has to be around.
Right. That is something that I precisely wanted to touch. This very last comment you made, right? That there's not going to be enough around, basically, to really supply the entire needs that are going to be, for example, for the electric industry in say 10 years, right? Which is what is estimated to grow at a very rapid pace, right? In maybe 10 years. So ever since you started your efforts, which is only 2 years, it's just 2 years, right? In cyclic materials, I can really, because of the numbers you shared with me, that around 12 to 15,000 tons per annum, I can really imagine just how much elements you take, right? But in an overall, I don't know if you have maybe like a number or rather like an estimate. How much do you believe that the over ever since pretty much the inception of these recycling companies, especially for these critical metals that you mentioned, how much percentage do you believe is now being used in the end consumers, right? From recycled metals instead of mined metals? Like, how much of a dent have you made, if you will, to the industry?
So in our case, we are not commercial yet, right? So
Hmm.
we are basically scaling up our technology, and we
Yeah.
will start selling some of our products starting 2024, Q2 of 2024.
All right.
So we will make a dent very soon. Uh, but at the moment, out of the metal that we consume in North America or in Europe,
Hmm.
close to 0%
Wow.
is recycled. 100% is mined
Yeah.
material. It comes from mining industry. In a sense that the metal basically is mined globally. About 60 to 70% is mined in China. The
Hmm.
rest is mined globally. Then the material flows into China because magnet manufacturing facilities are in China. The magnet is produced, put it into the applications, and then it's exported globally.
Yeah.
So origin of magnet metals, unfortunately, at the moment, rare earth metals, unfortunately, at the moment, is mining,
Hmm.
and we rely 100% on mining. In the next 10 to 15 years, we expect 3 to 5x increase in the consumption of rare earth elements.
All right.
Put it differently, if US is importing 15,000 ton a year of rare earth elements at the moment, it will increase by 3 to 5 folds in the next 10 to 15 years.
Hmm.
That tells you that we really need to increase the capacity and the production of rare earth elements globally, but simply we don't have enough resources that are economically viable to do so. For instance, in US, Canada, we have looked into many in the past. The companies, other junior mining companies
Hmm.
have looked into mining of those metals. The challenge is those mines are small, not economically viable,
Yeah.
environmentally polluting. So for any of those set of reasons, those mining projects, except one MP Materials these days,
Yeah.
haven't made it to the list yet. And even in the case that we are producing right now in the US, majority of the mined material goes to China for processing.
Right.
So those challenges are around in this space. Recycling wise, Cyclic Materials' ambitious goal is that we replace 3 to 4 mines equivalent of rare earth production in
Wow.
the next 10 years. That's our goal. So when we
Yeah.
globally recycle the material, that's how much material we will produce. So we will reduce the pressure on requirement or needs for mining. We are not going to replace mining.
No, of course not.
That's not our intention. Mining has to be around and has to grow, but we will reduce the pressure on need for mining industry
That
on rare
is
earth space.
that is it is a very interesting goal. I was expecting maybe to hear like a percentage wise, but it's amazing to know that you intend to sort of replace or take or take the spot for these 2 or 3 mines. It's amazing. So thank you very much for sharing that. Now I want to jump into a different part of Cyclic Materials,
Sure.
right? Which is about the technology itself. When it comes to recycling, I'm not sure if everybody has ever seen a recycling sort of facility. I have. There are many machines there, like a ton of machines that are used a lot. For example, in plastic, a lot of extrusion machines. In metal, I'm not familiar with it, not specifically for metals, but out of all of these machines, many of them have to be custom made. So, what are some of the engineering challenges over these past few years that you really sort of faced that you were like, huh, this was something not expected? Like you mentioned that the processes are very similar to other, already existing processes and materials, but what are some of these engineering challenges you faced?
Oh, absolutely. I can tell you, since the beginning of COVID, uh,
Yeah.
lead time of equipment to be manufactured and shipped to your facility has been really challenging.
Right.
Managing that, it adds a lot of risk to many of the capital projects. And in clean tech space that we are, you usually build physical plants, as you explained, lots of machines and equipment you have in there, and that's one of the biggest challenges we have right now. That
Hmm.
the lead time of equipment that we purchase usually changes significantly throughout the process of procurement to the arrival of the
Yeah.
equipment. Oh my goodness. Sometimes really keeps me up at night. That's one of the challenges every single clean tech company these days is facing.
Yeah.
That's a significant challenge out there. Uh, but it would be underestimation if I don't mention that the challenges that we have gone through in our basically scale up process. Because after all, when you scale up the technology from small, tiny little flask in a lab all the way to several kilograms or tons per hour or
Yeah.
so, that's a significant challenge. We have some really exciting and great news that will be publicized in very few days. I expect in 2023, and I will make sure that I get back to you on that as well. But we have been making really good progress on that side. As part of our milestones for this year and next year, we have two pieces of technology in our company. One of the technologies is how to isolate magnet from end-of-life products. We have done incredible amount of work on that side, and I will have an update. We will have an update in very few days on that. The second piece of the puzzle is now we have isolated magnet. Let's process that and convert it to raw materials, technically called mixed rare earth oxide, that you would need to produce or manufacture fresh magnets. On that side, also we are doing amazing amount of work. Please stay tuned, that we will have those updates very soon.
Oh, that is the worst thing for me. I always want to know already, you know, like right now. But we're gonna have to stay tuned for Cyclic Materials website, your blogs, your
Absolutely.
LinkedIn. By the way,
you know what, Sam? I will come back on the show again. I promise that.
Oh, okay, all right.
Yeah.
Too bad.
Yeah.
You already said it. No backsheesh.
Okay.
No, thank you very much for that. That's actually pretty cool. Now,
amazing.
Out of this, you already mentioned how sort of these first steps, right, for your process. But I'm very curious because it is not a very common, I want to say, or very rather, we're not very educated as general public on how the metal recycling process goes. Could you please give us an overview with your two machines of how this whole process goes from when you receive these scrap basically all the way until you already have these fine-tuned and ready to go metals?
Of course, absolutely. So it really all goes back to the end-of-life products, basically the products that we consume in our everyday life. So let's take an example. Let's say I don't know, a traction motor of an electric vehicle. I will leave that to your imagination. What electric vehicle brand you think of? Doesn't
Tesla.
make a difference. There you go, Tesla. So the motor itself, the electric motor itself, contains few things in it: aluminum, copper, steel, magnets, some plastics, some very minor other metals in there. Very minor. So the recycling process that we have is basically takes the whole end-of-life product and basically isolates those 5 different materials, inclusive of plastics, metals and plastics, into 5 different buckets. So now you have 5 different products to deal with. Copper, aluminum, steel are recycled to a significant volume in the market today. Around 40-50% of those 3 metals today is being recycled out there, and we tap into the same market. So we hand over our metal to those recycling companies, and they receive it and recycle it.
It's sort of the safe zone, if you will, right, for metals.
Correct, absolutely. So those are already out there, so we are not really reinventing the wheel on that side. When it comes to magnets, though, there is nothing out there. So that is where we have our own internal technology for recycling of magnets. Now, the bucket that has magnets in it, we take it to our second technology, which is a hydrometallurgy process. It's basically a chemical process that basically think of dissolving sugar in water, that kind of process. You dissolve the metals and then you recover those as a high quality product, which is called mixed rare earth oxide. Now, I'm really excited to say that last year we piloted continuously this piece of technology in Canada, and we produced over 100 kilograms, over 220 pounds of product, and we shipped it downstream to multiple companies, and we received a lot of positive feedback about the product. So that product basically is the core product of our second technology
Hmm.
that is looking into basically sending it over to companies that make magnets out of them. But we have some other products coming up, our hydrometallurgy or second piece of technology as well. That is cobalt nickel. If you remember, cobalt nickel are used in batteries and many other applications. So
Yeah.
those are among the critical metals as well. And also boron. Boron is used in the screen
Oh.
of our computers. Boron is used in many different glass applications on your phones, on your uh, uh, tablets and all that. So
Yeah.
we consume quite a bit of that in the screens and TVs and whatnot. So that also has gigantic application in the industry for different purposes. So those are the products that come out of our second technology. Overall,
Hmm.
for every 100 kilograms of feedstock that comes in, we basically virtually recycle everything and anything except
That's
tiny,
amazing.
tiny little bit of plastics,
Right.
which is less than 1%. And those plastics really, we don't envision to recycle those plastics internally. Those already go into the landfill.
Hmm.
Landfill. But I'm excited to say that we have started conversations with some companies out there that they claim to have technology to recycle plastics. So we are
Nice.
excited about that one as well. So basically, virtually whatever comes in, we recycle and put it back into the economy.
Hmm.
So in true sense, we are helping industry with circularity and our
Wow.
society.
Yes, yes, definitely the society. That's
Yeah,
actually pretty cool. Thank you very much for sharing that. Now, I want to dive a little deeper into this nerdy part that you mentioned, right? Of the that you have your internal own tech. Because I'm an engineer, I need to know this, right? I need to know, but it would be very interesting. Um,
sure.
when you come from an industry that already has very sort of set standards and set processes to for example the lithium recycling, it's already a well thought process on how to recycle it. It's already efficient, it's already well built, right? When you tackle for example magnets, then you go like, well, we need something different, and that's when you start working on your own solution. How long did it take you to figure out the best, or the current method rather, that you currently have for recycling these metals, these magnets, and how do you believe it could be improved?
Sure, absolutely. So we didn't start the company from ground zero, to be
Hmm.
honest. So I have been in personally, I have been in this space for quite some time, over 15 years. I did my PhD on hydrometallurgy. That's a fancy
Oh,
word for extraction of metals through chemical
yeah.
process. I did my PhD back in the days at the University of British Columbia.
Hmm.
So that basically was my knowledge on extraction of metals. Then I did apply that in a gold mining company in practice. So I
Hmm.
worked for a gold mining company and mostly did take care of creating new technologies for processing of ores and
Wow,
making metals. That was Barrick Gold, and I worked from their technology center out of Vancouver, British Columbia, Canada.
that's cool.
Then after that, I was a professor in university, basically helping other companies to create technologies for them. And throughout the years, I've done quite a bit of that work. So when we started the company, already I understood the concept of how we can make a environmentally friendly and economically viable and scalable technology.
Hmm.
The three key pillars of making a viable technology.
Right.
So we started with that, but I have to say that the first year of the company was working on proof of concept. For instance, in our hydrometallurgy process, we literally started with 100 ml milliliters, tenth of a liter
Wow.
test sizes in the lab, and then increase the volume to 1 liter, then 10 liter, then continuous,
Yeah, yeah, yeah.
then 10 tons a year capacity in pilot plant. Now we are going 10x larger in the next year as well. So it's
Wow.
been really a process of scaling up of the technology and fine tuning. Uh,
Hmm.
you asked if we will improve the process. We are improving the process every day and any day. Simply scaling up is all about improving the technology and
Yes.
fine tuning the technology and increasing the efficiency of the technology. That's what we are working on as well.
That is amazing to know.
Yeah,
It's actually pretty cool to see how in this podcast we interview a lot of CEOs, right? Mainly like yourself. But it's always great to see how you it's amazing that you come from this very scientific, very technological background. It's amazing. I didn't know that, for example, about your PhD. But it's really cool.
thank
Um,
you.
Now, before we continue over here, all right, we have a few people watching over the stream. We've had some others come and go. To everybody watching, if you feel like you have a question you want to ask Ahmad, feel free, leave it in the chat. If not, we're gonna just continue chatting over here because I do have a bunch of questions. All right,
Okay.
questions we're not lacking, but just in case. Now coming back over here very quickly to Cyclic Materials. Now we already discussed how you started, how the company started, how you do it essentially, right, and what you do and why is it important, right? Now there is only one thing that I believe we still need to tackle over here about, not necessarily about the future because you already also mentioned your goals in 10 years, for example, but about how you see the landscape changing, right? Especially in the part of the supply chain. You already mentioned many of these metals come from China, for example, and a lot of these is a very centralized supply chain. It all comes and goes to these places, right? How do you expect, or how do you believe the supply chain is going to be affected once not only you go to market, or that you start selling your products, but when this industry starts growing as a whole? Talk about maybe 15, 20, 25 years going into the future, right? Especially ask this because of just how ramp up is sort of the industry, for example, of electric vehicles going, right? So naturally, there's going to be a lot more to recycle. We have already talked about these over the podcast. How much do you believe that the supply chain is going to change? Is it going to be for the better? Is it going to be hard to adapt to these changes in the supply chain? Where do you envision this in the very long term?
Absolutely. That's a great question. So I'm going to again take a step back and the whole
Yes.
talk about the whole concept of energy transition and electrification.
Okay.
We are going through the whole process with the goal of reducing the carbon dioxide in the
Mm-hmm.
atmosphere, cooling down our planet, and saving that for the future generations.
Yes.
Uh, but to do so, we need metals. The energy transition is built on metals.
Yes.
We need more and more metals. We need 3.5 times copper in electric vehicles. We need lithium, cobalt, nickel in electric vehicles that we didn't need much of those in ICE cars. We need just more metals in electric vehicles and in wind turbines, in solar panels, and in many different applications. In the grid that we're going to transfer the electricity, that our consumption of electricity in the US in the next 10, 20 years will be 3 times what it is today. We will need the grid capacity to transfer that electricity as well. So we need metals. We established that. But metals
Mm-hmm.
mostly come from mining.
Yes.
Mining is polluting the environment. So that's a little bit counterintuitive.
Yes.
The idea with energy transition is that we go through this period of time that intensely mine metals and electrify our society. But as we go forward post 2040, we do recycle a lot of those metals and we go through circularity at that time. So if you fast forward to 2040 and beyond, my expectation, based on what academics believe, is
Mm-hmm.
that a lot of metals has to be recycled for us to make sense to go through this electrification period.
Yes.
So if you ask me what I believe about the future, I believe in future we will do recycling a lot more than what we do today. Recycling will be a core in our planet.
That's
Uh,
cool.
a lot of people will be concerned about recycling, and recycling industry will be one of the bigger employers of future in the future societies. But we have quite some time until then, and the companies
Yes.
have to survive the timeline until they get there. Our expectation within Cyclic Materials is that in 2030, when we have fully integrated supply chain of our processing plants around, we will be processing and recycling very, very few percentages of global rare earths production. And that's intentional because we can't really plan to recycle half of the market ourselves. We expect other competition to be out there. We expect other companies to be out there and around us. So with that in mind, we will do quite a bit of recycling, but it will be a small percentage of the market. The idea is that we will ease up the need for supply chain from one country for some critical applications. OEMs can have contracts for feedstock from 2-3 different locations, companies. And I believe that it's not the matter of if, it's the matter of when we produce more rare earth elements globally outside China. We will have to do that. A lot of companies are putting a lot of time on it, mining companies. And I think this is something that eventually will have to happen because recycling single-handedly cannot produce 100% of the material that market will need in the next 30 years.
And what can we do as the end consumers? What can we do to contribute to these efforts of recycling these metals?
Oh, absolutely a fantastic question. It goes hand in hand with the cities as well, because cities help on recycling is invaluable. It's important.
Yes.
It's the plans of the cities. But one thing that the public could do is not to mix the electric motors into their waste that is not recyclable, landfill waste. Not to, for instance, the power tools, electric power tools that we use in the household every day, those should not go into the waste, for instance. So those are the aspects that if we have the public to help with that, that would be really a fantastic, phenomenal help for circularity of our economy. It's not about just rare earth elements. It's overall about everything and anything. Batteries, metals don't go into the landfill waste. So let's not mix those up.
All right. Well, everybody, you already heard. Let's make sure that we make our part, right? Now, I only have 2 final questions over here. One of which is just, it sort of just grew right now that you mentioned this. Is there such a thing as just you having, as the recycling company, far too much material to recycle? Like, is that such a thing? Like, right now, do you have a limit to? Well, naturally, there's always a limit, but do you have a limit to how much you can receive yearly?
In our financial model, and based on the capacity of our plants, each company has limits on how much material they can process. But overall, for any industry, not just Cyclic Materials, for any recycling company or any manufacturing or production facility, if the economics of the process is positive, and you receive much more feedstock than you can process, then you increase your capacity.
Yes.
So we have designed our company such that we can dial up the production capacity up and down as we need in the future. So we have designed the company with that in mind, because that's a critical question, actually, that we can increase our capacity with minimum capital expenditures in the future, simply because we are putting into place some aspects of it today that in future we can utilize.
Right. It's already part of the plan. That's actually pretty cool. Thank you. Thank you for sharing that. Yes.
Absolutely.
Now, it seems like we answered every question, because there were none left over here in the chat. No worries, though. You already mentioned we're gonna have you back, so we're gonna be ready by then. But for now, just so we close this out already, because I know that you have a few other things to do in your day. There is one final question that I want to ask you. Okay.
Sure.
And this is getting out a little bit of the whole recycling sort of mindset and tackling more into your CEO founder brain. Okay, just poaching it a little bit. What advice do you have for any person out there who wants to start their own journey? In your case specifically, in this case, if they want to leave their own mark in the world doing these recycling efforts, what advice do you have for them if they want to start?
My advice is be a risk taker, and at the same time, just step in and do it. I always jokingly, but in my mind seriously, tell my team that in the company that in startups, the spacing of good news and bad news is 24 hours. In 24 hours, you hear a good news and a bad news. So be ready for those roller coasters and just do it. It's pretty exciting space to be. And if you basically do a good job of understanding risks and minimizing risks as much as you can, you actually do have pretty good shot in making a successful business.
That's actually a very cool advice, very straight to the point. Take risks, be willing to understand that these risks are going to come with ups and downs. And I like the phrase you said, be ready for the roller coaster. That's actually
Yeah,
pretty cool. And I believe that is
100%.
the perfect way to give a closure to this interview. Ahmad, thank you very much for that. This was honestly very eye-opening in many senses, especially
Thank
because,
you.
well, you know it already very well. This is a topic that is not very well known in the public, generally speaking. So I'm glad that I got to learn a little bit from you. And for us to continue learning, where can we find you and Cyclic Materials? What are your social media handles?
Absolutely. So, of course, our website is the best place to get updated
Yes.
information, cyclicmaterials.earth. We
Yes.
really believe in Earth. So that's our .earth. That's our website. Our Twitter account is Cyclic Materials, and our LinkedIn also is Cyclic Materials. So just
Sounds
Google
perfect.
us, you will find us. Keep in touch, please. And Sam, I really have to say I enjoyed our conversation. Thank you so much.
Thank you very much. I really did as well. I love learning about, especially about things that I am not familiar with, which in this case was the perfect example. I appreciate a lot your enthusiasm and your insights. It was amazing. And for everybody out there who's still watching, remember that you can find more information, interesting articles, more interviews, clips, shorts, blogs, and a lot more content on our website, buildernation.io, and as Builder Nation across all social media. We're going to love to hear from you. Thank you for being part of this community. Ahmad, thank you for joining us in the ride. Thank you for sharing your very vast knowledge. I appreciate it a lot. We're so lucky to have you. Thank you.
Thank you so much.
And goodbye to everybody who's watching.
Cheers.
When building the future is your priority, tedious procurement processes should be last on your list. The problem is that purchasing data is scattered across spreadsheets, receipts, emails, and messages. Tracking it all sucks and makes it easy to commit mistakes. Introducing the Control Hub Way, the all-in-one purchasing software for hardware companies. Buying parts, services, or office supplies? Submit a quick purchase request to buy from your list of approved vendors, or buy from a new provider. Buying from approved vendors is even easier. Import your shopping cart directly into your purchase request using our checkout integrations. When the order is ready, submit it for approval. We'll ping all pre-designated approvers both via Control Hub's website, email, and Slack notifications for a faster turnaround. If you need a PO, we got you. Generate it in one click. Online purchase? Boom, virtual card. Do an automatic 3-way match, pay invoices, and sync everything live with QuickBooks or NetSuite. Purchasing just got a lot easier. Control Hub. Get back to building.